Hello my dear students, I am Deepak Vanjani. I welcome you in video lectures of Devasi International Public School. Last time we have studied about parallax method. Today we will solve some numericals examples related to parallax method. Let us solve example 2.1. In example 2.1, what they have given? Calculate the angle of 1 degree. First, that is 1 degree angle. Second, that is 1 minute. This sign represents 1 minute, or it is called 1 arc minute, and 1 second. This is a symbol of second. 1 arc second. All these three are angles, not time. 1 degree, 1 minute, 1 second. Actually it is called 1 arc minute, it is called 1 arc second, but in short we can say 1 minute, 1 second. In radians, we have to calculate these angles in radians. It means we have to convert degree into radian, minute into radian, and second into radian. Use 360 degree is equal to 2 pi radian. This relation already we have obtained in the theory of plane angle theta. That is 360 degree is equal to 2 pi radian. 1 degree is equal to 60 minutes. Relation between degree and minute is given to us. 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. So first of all we will convert degree into radian, then we will convert minute into radian, and after that we will convert second into radian. Okay. First, 360 degree is equal to 2 pi radian given to us. So 360 degree is equal to 2 pi radian, then 1 degree is equal to what? Therefore 1 degree is equal to 2 pi upon 360 radian. 2 pi upon 360 radian. 2 180 is 360. So pi by 180 radian. Or we can write 180 into 2, that is 360. 2 will get cancelled. So instead of this we can write pi by 180 radian. Value of pi that is known to us, that is 22 by 7, or you can write 3.14. 3.14 upon 180 will give you 1.745 into 10 raised to minus 2 radian. So 1 degree is equal to 1.745 into 10 raised to minus 2 radian. Okay. So we have converted degree into radian. 1 degree is equal to 1.745 into 10 raised to minus 2 radian. Now we will convert minute into radian. But one relation is available to us. 1 degree is equal to 60 minute. So 1 degree is equal to 60 minute. Therefore 1 minute is equal to what? So here we can write 60 minute is equal to 1 degree. 60 minute is equal to 1 degree. Then 1 minute is equal to what? So 1 by 60. 1 by 60 degree. From this we can write 60 minute is equal to 1 degree. So 60 minute is equal to 1 degree. Therefore 1 minute is equal to 1 by 60 degree. It means we can say that 1 minute, that is nothing but 60th part of degree. 1 minute is 60th part of degree. So this 1 minute angle is very small in comparison to 1 degree, that is 60th part of degree. But this can be written as 1 by 60 degree can be written as 1 by 60 into 1 degree. This can be written as 1/60 into 1 degree. 1/60 as it is, but value of 1 degree, that is 1.745 into 10 raised to minus 2 radian. So 1.745 into 10 raised to minus 2 radian upon 60, that will give you 2.91 into 10 raised to minus 4 radian. So we can write 1 minute is nearly equal to 2.91 into 10 raised to minus 4 radian. So this way we have converted minute into radian. Now next we have to convert 1 second into radian, but relation is available to us. 1 minute is equal to 60 second. 1 minute is equal to 60 second. It means second, that is very small in comparison to minute. 60 second is equal to 1 minute. This can be written as 60 second is equal to 1 minute. Therefore 1 second is equal to 1/60 minute. It means 1 second, that is nothing but 60th part of degree. That is 60th part of minute. 1 second, that is 60th part of minute. If we want a relation between second and degree, then 1 second is 3600th part of degree. How? Because 1 second, that is nothing but 1/60 into 1 minute. Yes or no? So instead of this we can write 1/60 into 1/60 degree. So this can be written as 1/3600 degree. So we can say 1 second is 3600th part of degree. It means second is very small. Second is nothing but very small in comparison to degree. Very small angle in comparison to 1 degree angle. But here we have to convert this second into radian, not in degree. So 1 degree is equal to 1/60 minute, and value of 1 minute is available to us, that is 2.91 into 10 raised to minus 4 radian. Instead of this 1 minute we can write 2.91 into 10 raised to minus 4 radian upon 60 as it is. Now if we solve this, we will get 1 second is equal to 4.85 into 10 raised to minus 6 radian. So we can say 1 second is equal to 4.85 into 10 raised to minus 6 radian. This is important relation. Whenever we have to convert second into radian, then directly we can use 1 second is equal to 4.85 into 10 raised to minus 6 radian. Here what they are asking us to find, we have to convert degree into radian, minute into radian, and second into radian. All these are angles. यहाँ पे हमने जो मिनट कंसीडर किया है वो टाइम वाला मिनट नहीं है. यहाँ पे जो मैंने सेकंड कंसीडर किया है वो समय में जो सेकंड आता है, टाइम में जो सेकंड आता है वो नहीं है. यहाँ पे जो मिनट का मतलब है वो है एंगल. दैट इज हियर दिस मिनट इज कॉल्ड 1 arc minute. This is called 1 arc second. It means when we consider any arc, if that subtends some angle, and if it is 60th part of degree, then that is called 1 minute. That is called 1 minute. So this way we get this angle in minute and second. If the angle is, if any arc subtends an angle 3600th part of degree, then that is called 1 second. And here we have obtained the relation between 1 degree and radian, 1 minute and radian, and 1 second and radian. Let us solve example 2.3. The moon is observed from two diametrically opposite points A and B on earth. For example, this is the earth and this is moon. And moon is observed from two diametrically opposite points of the earth. It means moon is observed first from A, then it is observed from point B. The angle subtended, the angle theta subtended at the moon by the two directions of observation is 1 degree 54 minutes. So this theta they have given, that is 1 degree 54 minutes. Given the diameter of the earth to be about 1.276 into 10⁷ meter. This diameter of the earth they have given 1.276 into 10⁷ meter. But this diameter of earth is nothing but distance between 2 points of observation. And we have already studied in parallax method that distance between 2 points of observation is called basis. So this distance between 2 points of observation is nothing but basis B. So 1.276 into 10⁷ meter is nothing but basis. Compute the distance of the moon from the earth. It means we have to find distance between earth and moon. To measure large distances, we can use parallax method, that is indirect method. But in that we have used the formula of plane angle theta, and whenever we want to use formula of plane angle theta, at that time theta should be in radian. Here theta is not in radian. Theta is equal to 1 degree 54 minute. So first of all we have to convert this 1 degree 54 minute into radian. First I will convert degree into minute, then I will convert minute into radian. In example 2.1 we have obtained the relation between degree and radian, minute and radian. In example 2.1 they have given 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. So instead of this 1 degree we can write 60 minutes. 60 minutes plus 54 minutes, that is nothing but 114 minutes. It means this angle theta in minute is nothing but 114 minutes. But this can be written as 114 into 1 minute. We can write 114 into 1 minute. 114 as it is into 1 minute. What is the value of 1 minute? 1 minute is nothing but 2.91 into 10⁻⁴ radian. So instead of 1 minute we can write 2.91 into 10⁻⁴ radian. Now we have converted this theta in radian. So theta is equal to 114 into 2.91 into 10⁻⁴ radian. It can be written as 3.32 into 10⁻² radian. Now we can use the formula of plane angle theta. What is the formula of plane angle theta? Plane angle theta is equal to length of arc upon radius. From this figure, plane angle theta is equal to length of arc. We can consider this basis as arc and this as radius. So already we have studied this in parallax method, that is plane angle theta is equal to B by D. Therefore D is equal to B by theta. B that is available to us. Theta already we have obtained in radian. Substitute the value of B, that is 1.276 into 10⁷ meter, upon theta, that is 3.32 into 10⁻² radian. After solving this you will get 3.84 into 10⁸ meter. So distance of moon from the earth is 3.84 into 10⁸ meter. This is the answer. Simply by applying the formula of plane angle theta, we can obtain distance between moon and earth. Using parallax method, we can measure large distances directly. I hope example 2.1 and 2.3 is clear to you. Now I am giving you example 2.4 in homework. In parallax method, already we have obtained the formula. Using that, you can solve example 2.4. So I am giving you one example, example 2.4 in homework. Try to solve that. Now next topic, that is range of lengths. The smallest length, that is 10 raised to minus 14 meter. This thing already we have discussed in chapter number 1. This is nothing but size of nucleus. Size of nucleus is of the order of 10 raised to minus 14 meter to 10 raised to 26 meter. Range of length is from 10 raised to minus 14 meter to 10 raised to 26 meter. This is nothing but size of the nucleus, and size of the nucleus is of the order of 10 raised to minus 14 meter. 10 raised to 26 meter. 10 raised to 26 meter is nothing but that is the size of observable universe. Size of observable universe is of the order of 10 raised to 26 meter. So range of length is from 10 raised to minus 14 meter to 10 raised to 26 meter. Now, special length units for short and large lengths. These units you should remember for very short questions and numericals. First unit, that is 1 Fermi. 1 Fermi, that is the unit of length, and 1 Fermi is equivalent to femto. In the table of submultiple, we have studied about femto. 1 femto is equal to 10 raised to minus 15. Here also 1 Fermi, that is denoted by symbol 1 Fm. This is Fermi, is equal to 10 raised to minus 15 meter. Value of 1 Fermi is equal to 10 raised to minus 15 meter. 1 angstrom. 1 angstrom, that is also the unit of length. 1 angstrom is denoted by 1 A, and one small circle we have to put on A. This is the symbol of angstrom. 1 angstrom is called 10 raised to minus 10 meter. The value of 1 angstrom is 10 raised to minus 10 meter. Next unit of length, that is 1 astronomical unit. 1 astronomical unit, that is nothing but denoted by 1 AU. In short, we can write 1 AU. This is nothing but astronomical unit. What is the meaning of astronomical unit? This is the average distance of the sun from the earth. For example, here I am considering this as sun and this is earth. So this is nothing but average distance between sun and earth. Average distance between sun and earth is nothing but 1 AU, 1 astronomical unit. What is the average distance between sun and earth? That is 1.496 into 10 raised to 11 meter. Value of 1 astronomical unit, that is 1.496 into 10 raised to 11 meter. This is the large unit of length. 1.496 into 10 raised to 11 meter, that is nothing but 1 EU. Next, that is 1 light year. This is also used for the measurement of astronomical distances. When we have to measure large distances, at that time we use this unit 1 light year. In short, it can be written as LY. LY is nothing but light year. So 1 light year is nothing but 1 LY, and 1 light year is nothing but that is equal to 9.46 into 10 raised to 15 meter. Value of 1 light year, that is 9.46 into 10 raised to 15 meter. What is 1 light year? That is the distance that light travels with velocity of 3 into 10 raised to 8 meter per second in 1 year. If we have to find a distance from the formula of velocity, then we know the formula of velocity. Velocity is equal to distance upon time. Here light year is not the unit of time, this is a unit of length. So 1 light year, if you want to find in meter, then velocity is equal to distance upon time. Therefore distance is equal to velocity into time. What is velocity? 3 into 10 raised to 8 meter per second. Velocity, that is in meter per second. Therefore we have to convert year into second. In 1 year there are 365 days. In 1 day there are 24 hours. In 1 hour there are 60 minutes. And in 1 minute there are 60 seconds. So here using this formula, velocity is equal to distance upon time, displacement upon time. So displacement is equal to velocity into time. Velocity, that is available to us, 3 into 10 raised to 8, and time, that is 1 year. Convert 1 year into second. When you will substitute the value of velocity and time, you will get this value, 9.46 into 10 raised to 15 meter. So directly you can remember 1 light year is equal to 9.46 into 10 raised to 15 meter. Next unit of length, that is 1 parsec. This is also used to measure astronomical distances, very large distances. And 1 parsec is equal to 3.08 into 10 raised to 16 meter. What is the meaning of parsec? Parsec is the distance at which average radius of Earth's orbit subtends an angle of 1 arc second. In example 2.1 we have studied about 1 arc second. Here, if radius of the orbit subtends an angle 1 arc second, this is the symbol of arc second. Suppose this star, at the star radius of Earth subtends an angle 1 second, then distance between this star and Earth will be 1 parsec. And 1 parsec is nothing but 3.08 into 10 raised to 16 meter. Once again I am repeating, 1 Fermi, that is the unit of length, that is equal to 10 raised to minus 15 meter. 1 angstrom, that is 10 raised to minus 10 meter. 1 AU, astronomical unit, that is nothing but 1.496 into 10 raised to 11 meter. 1 light year, that is 9.46 into 10 raised to 15 meter. And 1 parsec, that is 3.08 into 10 raised to 16 meter. Students, please remember these values. If you will remember these values, then easily you can solve numericals and MCQs. Estimation of very small distances. Now, if we want to find small distances, then how can we find small distances? To measure small size like that of a molecule, we know that size of atom and molecule is very small. If we want to measure the size of molecule is about 10 raised to minus 8 meter to 10 raised to minus 10 meter. So how can we measure this size? Can we measure this size using screw gauge? No, because we know the least count of screw gauge, already we have studied na? So least count of screw gauge, that is 10 raised to minus 5 meter, and here we have to measure this distance, 10 raised to minus 8 meter. 10 raised to minus 8 meter is smaller than 10 raised to minus 5 meter. So we cannot measure size of molecule using screw gauge. So using this instrument we cannot measure size of molecule. Okay. Yes, you can measure the diameter of wire using this screw gauge, but you cannot measure size of molecule using screw gauge. Next, that is optical microscope. Can we measure size of molecule using optical microscope? About microscope and telescope you have studied in standard 10. And to observe small things we use microscope. Using optical microscope also we cannot measure the size of molecule, because this optical microscope require light and wavelength of light, that is 10 raised to minus 7 meter, 4000 angstrom to 7000 angstrom. If we convert it into meter, then 4000 into 10 raised to minus 10, that is 4 into 10 raised to minus 7 meter. But size of molecule is from 10 raised to minus 8 meter to 10 raised to minus 10 meter. So we cannot measure the size of molecule using optical microscope. Now next, that is electron microscope. Using electron microscope, can we measure the size of molecule? Resolution of electron microscope is 0.6 angstrom. And what is the value of 1 angstrom? 1 angstrom is equal to 10 raised to minus 10 meter. So if you multiply 0.6 into 10 raised to minus 10, then it can be written as 0.6 into 10 raised to minus 10 meter. So yes, here using this we can measure the size of molecule. So using electron microscope we can measure the size of molecule. Using tunneling microscopy also we can measure the size of molecule. Theoretically, if you want to measure the size of molecule, then there is one method, that is the method of oleic acid. Using this method we can theoretically estimate the size of molecule. So these are the methods through which we can measure the size of, using electron microscope, using tunneling microscopy we can measure the size of molecule. And if we want to find theoretically, then we have to use the method of oleic acid.